Great. And so I'll do that in a little bit. And I've got slides to share whenever you're ready for 'em.
Okay, great. So maybe we'll get started. I'll do a quick introduction. I guess we don't need much introduction for Forrest. Forrest is really well-known. Forrest Bolick is from University of Massachusetts Amherst, and he's a senior lecturer in the Department of Earth, Geography, and Climate Science. And he is one of the leaders in geospatial education, teaching. I had an honor of doing the R of CI, one of the R of CI projects with um, a cyber training project with Forrest, and I count him as a good friend. And thank you, Forrest, for doing this. And today, as you can see from the slide here, Forrest will be talking to us about supporting teaching and learning of geospatial data science. And he's going to be evaluating some of the curricular tools available out there, and hope like iGuide could benefit from this, as well as the broader geospatial data science community. So Forrest, thank you again for doing this, and welcome to the iGuide uh, virtual consulting office session. And we try to do this session every other week.
Yeah, thank you so much for the invitation, and it's good to see you and all my other good friends on the call. But it's certainly a good community to be a part of, and I really appreciate and thank you for that very kind introduction, and I really do appreciate it. So my name's Forrest. I think that Anand covered the basics, so, and the core pieces, but the goal in my mind of this VCO today is to go over some curriculum ideas, some curriculum thoughts, and some curriculum tools in really trying to work through and work out how we can support both the teaching and learning of geospatial data science, of GIS, of computational, whatever. We all use lots of different diverse terms, lots of different ways we like to describe the work that we're doing. And I think that one of the goals of this is to provide, a generalized enough means to be able to support building the teaching and learning in all of those different ways we conceive and conceptualize the work that we do. So as the event's description said, I'm planning to go over just some basic things, an overview of the tool, an overview of some components that go into this tool, and then time to work. It's, depending on where you are in your semester, you might have just finished a semester, you might be just starting a semester, you might be in the middle of it, depending on how all of the different calendars align. I just, here at UMass, we just finished, we had graduation last weekend, and I just started my summer course yesterday. So always in the thick of it in terms of teaching and thinking about learning pathways and how people get into these ideas, these courses and whatnot. A lot of this presentation comes from my experience, not only teaching GIS courses, primarily anymore I teach intro GIS pretty much year round is my primary teaching. I taught it in the fall, I taught it in the winter, and I'm teaching it in the summer. So and I think that's a really rich place to observe how learners are coming into a initial stepping stone, a initial gateway into the broader geospatial, data science, data analytics, all of the things that come with that. And certainly intro GIS isn't the only way that people get into this work anymore, nor maybe it never really has been, but certainly it's one of many. But I think that some of the things that pop up in my experiences and in your experiences, of course, definitely serve many different contexts and serve many different just ways that people learn and the challenges and the successes therein. So Anna covered this. My background's in geography and GIS education. And as Anna mentioned, I've done projects like the Hour of Cyber Infrastructure project, which we did with Eric Shook at University of Minnesota and Karen Kemp at USC. I've published a lot on geography and GIS education in general, and I think it's a really rich area to study and look about. or and to look at. So when I say the tool, talking about this tool, this idea of curriculum evaluation, this is something that emerged from my project as a UCGIS iGuide community champion from the previous cohort. And I had presented this goal to provide some sort of scoping structure, some sort of way to help learners and instructors understand pathways into learning complex geospatial topics. At some point, we know nothing, and then we learn and we know things. And so we have to build on that learning. And it seems, simple when you say it like that, and maybe it is, but those pathways, those dimensions of learning, what you need to know the next thing, stuff like that, it's actually quite difficult. And so the goal of this tool was to put something together that people could learn, that people could use, that people could actively do to work with their own curriculum, whether that was to the level of a lesson, to the level of an assignment, to a course, to a degree, up and down. I wanted to just build something so that people didn't have to start from scratch. And in doing this, I tried to bring in a lot of different resources from not only the learning sciences, but GIS education resources, connecting with, past efforts, connecting with a forward-looking view at where GIS, where geospatial is going, and really trying to make it flexible enough so that people could pop in their own individual, unique, important viewpoints or areas they need to hit. So I'll share this. You will get this in the Zoom file share here in a little bit, so you can play around with it on your own. And as I said, part of this is work time. So I want you to, think about a lesson, even slides. It could be part of a lesson. It could be a course. It could be whatever you want to think about, and however you want to think and reflect on what do people know coming into this? What do people know coming out of this? I'll explain more about that as we go, but I challenge you to start thinking right now of something that you want to dig into just a little bit by the end of this hour. Now, of course, we have lots of different ways that we think about curriculum, that we think about knowledge and skills and practices, that we think about what people should know, that we define what should means, all of these different things. In the top left here, this is a screenshot I took from the NCGIA core curriculum that listed out some lecture topics in GIS into 3 bins: introduction to GIS, technical issues in GIS, and application issues in GIS. I really still to this day deeply value and reference the NCGIA core curriculum for doing that very difficult work of saying, this is in the early 90s, saying, okay, GIS is this thing. How do we actually organize the knowledge? How do we organize the way it's taught? So on and so forth. I still use in my intro GIS class, the students in my summer intro GIS class will soon encounter, materials born of that era. I use Ken Foot's Geographer's Craft materials, which were made in 1995 by Ken Foot and some others. And those MS Paint drawings of what it means to have accuracy in terms of a datum, how different datums operate, what's the difference between geoid height, all that kind of stuff. I still use them. They are still relevant. They're still useful. They're still some of the best materials that we have out there. And so I think that when we're thinking about educational materials and curricular materials, there's a lot of value in going back and forth across the resources that we have. Of course, another resource that we have is the GIST body of knowledge. A small snippet of the organization of that is also on the left there. Another way of just organizing the different components of what it means to teach and learn and build up areas of knowledge within GIS and geospatial. So analytics and modeling, GIST and society, all topical areas where we engage with, where we work with. Then there's the convergence curriculum for geospatial data science on the right. Of course, that's an iGuide product, an updated version of, or an updated organization, let's say, of how all this knowledge works, how we cross paths, how we organize things together, from foundational knowledge threads to knowledge connections, so on and so forth. And I think one of the most valuable things of seeing all of these things together is to see that we've been grappling with similar questions and similar, similar, I guess, areas to overcome for a long time. How do we organize the knowledge? How do we put names and labels to the things that we're valuing within these knowledge spaces? How do we come up with some kind of hierarchy so we know that we can learn this and then this, and you can't learn this without this? Of course, it's all kind of a loop in a way. I think that we're always going to be looking at what is GIS, what is geospatial, what is data science, and always kind of rethinking these pieces. That's good, that's valuable, and it's something that we have to do to support our learners. So again, an area that merits a lot of work and really helps with a lot of help, offers itself to need a lot of help to build solutions. So I've got a question for you, and we're going to start with this question. I'm going to put the link, the hot link to this little form in the chat, just in case you'd like to copy and paste. So I was thinking about this as I was putting this together. I said to myself, there is a lot of, I don't know if there are just instructors, just learners here. I imagine we're a mixed group, and I really value that. And something that I ask myself, or I reflect on my own teaching pretty much every semester, is what are the students bringing to my course? What do, in the fall, it's 110 or so intro GIS learners. What are they bringing here? How am I going to be able to connect with them? How am I going to be able to, share all of the information, all the things they need to know to do GIS, which is its own, adventurous thing to define. And I wanted to get this from two different perspectives. So I've got questions for you. I've got a hot link. I just put it in the chat, tx.ag/May22 VCO. We can thank my doctoral institution for always providing me with a link shortener. That's Texas A&M. So shout out to them. And I wanted to get your thoughts from the start here about what you've noticed about the knowledge, skills, and practices, either from students in your courses if you're teaching, or if you're taking courses, what the courses are expecting of you in terms of knowledge, skills, and practices. You might be both of these. You might be teaching and learning. That's great. Both of those perspectives are super valuable. So I want to take just a minute or two, and hopefully someone jumped ahead of the game, and maybe I have one or two already in my little form. This is just an anonymous Google form. There's nothing here that is collecting any information or anything. So feel free to just pop stuff in the form. And again, I'm really interested in kind of getting your sense of what have you noticed recently in the courses, either taking the course or teaching a course. It is starting to populate, which is great. I'll be quiet for a minute or so in case you need that silence to write out your response. All right, I'm going to start reading some things. This doesn't mean you can't keep submitting. As I tell students in my class, make sure you put your thoughts in no matter what. But I want to just read off a couple of these. So again, these were instructor and learner questions. We have instructor and learners here. One of the learners has noticed that there's usually somewhat of a mismatch in their experience. The knowledge, skills, and practices are either too high of a line, or they're not getting much out of it. So they either know the things or they can't approach the things, which is an interesting gap in the middle there. There's got to be a middle as we're climbing, as we're building our capacities. We can't just go from, oh, I learned about this thing, to I can make new creative things with this thing. Supporting the middle is really important. Another learner says that they appreciate that most of their instructors have taken the approach of you start at point A at some level and you end at point B at some other level. And that's growth, and that's a course. That's a great way to organize a course. I like that a lot. And certainly it's one of the things I try to encourage people to do is to think about a course in people start, people finish. That finish might vary. As long as everyone's finishing with more, it's successful. That's great. Well, more instructor responses. I kind of guess there might be more instructors here than learners, so let's go through some of those. One says, we experience a wide variety of background knowledge among our students. Very diplomatic way of putting that. I appreciate it. Some of the students come very ready, but some of the students lack in very basic skills needed for the course. And what's really interesting about comments like that, I can totally agree with that. From my perspective in Intro GIS, someone else says in here, awful with file management. Yeah, that's one of the things I notice in my students. And if I can pull out, hold on, here's the culprit. It's this. Tell me about the file system on an iPhone. If that's the computing you're used to using, or Chromebooks, tell me about the file system on a Chromebook. No experience with that. So it kind of gets to that idea of basic skills. What do you mean by basic skills? If we're talking about file management as a basic skill, yeah. If we grew up, using computers that required us to remember where something was downloaded, to remember where the file path was, then yeah, that's a basic skill. And students who are coming into our classrooms ready to learn, who have used an iPhone, who've only used a Chromebook, they're not going to have file management skills because you don't have to. Have you seen some screens that people use? Hundreds of apps, hundreds of screens of apps. Students have better computer and programming skills, but their quantitative foundation has become a barrier for mastering spatial analysis. Definitely. That's a very interesting flow of things. Math always scares people when we get into that in my GIS course. Eager to learn about more social applications. Definitely a dimension, definitely a dimension that is more and more sought after in our courses. The most challenging part of teaching a course, students have very different levels of GIS. It is challenging to adapt to materials, teaching to personalized growth opportunities. Yeah, and we could probably do another one of these on scaffolding, which is let's say a pedagogical technique where you try to build out materials to support learners at many different spaces. So there's not just one single assignment, but there are aboves and belows to help bring people towards a learning goal together. All of those are great inputs. And as I said, please put your thoughts in there as well. We'll have more chance to talk and think about these things as we go along. But let's kind of get to one of the pieces of this, which is, why are we evaluating this stuff anyway? If we're, we've got a lot of expertise, we've got a lot of knowledge, we have an eye on where the job market is going, where the research skills are needed. But evaluation is really important so that we can apply labels, apply some kind of standardized or at least universally comprehensible labeling method to the stuff that we're teaching with and the stuff that our students are learning from, so that we can understand the function, the sequence, how things are organized, what they look like of learning materials in general. So what this tool and what we're going to see here today is aiming to do is to support instructors at all of these different levels as they kind of explore what is built into the assumptions, what is built into the pathways, what is built into your stuff generally when you're presenting that to students. And I think the comments were really helpful and really supportive in that. When we think about what we know, our expert knowledge, we're all experts in some way or in some field, and certainly more expert than the novice student who comes into our classroom without having, the full extent of our course, the full extent of our background. It's really important to understand that the needs of novices, what novices need to know and how they need to learn, is going to be organized very differently than how we know or how we might learn. So if I have an expertise in a certain field, I've done the research, I've done the literature review, I've done the coursework, I've done the practice, I've done all these things in that. And how I am going to then do something is going to be very different than I need to teach someone to do something. This expert knowledge gap, or sometimes called the expert blind spot, is very well studied. Here's a quote from the Center for Innovative Teaching and Learning at Indiana University, Bloomington. Sometimes instructors get so enthusiastic about conveying knowledge that they skip foundational steps, leaving students feeling frustrated or behind. If I asked you, if you just finished a course, maybe you've gotten course evaluations, and often in those course evaluations, you will see, this course was too fast. I didn't know what was going on, stuff like that, which I take as, a sign that, oh, that section of the course, maybe I relied on my own expertise too much. Maybe I relied on my own background knowledge to get an idea across. This happens a ton with me when I teach projections. There's so much intricacies to projections and coordinate systems and all that kind of stuff that sometimes if there's a question and I'm not maybe perfectly able to cut down to every part of the question, I'll just say, well, as we know, and that's bad practice. I should stop doing that. I want to encourage you, if you're instructing and you are ever having questions about, oh, how do I design this thing? How do I build this thing so that novices can learn? You have something similar to the Center for Innovative Teaching and Learning at your university. And if you're at Indiana, then that is your center. We have the Center for Teaching and Learning at UMass. And every university has a place like this that can help you, that has experts in pedagogy, experts in curriculum, who can help you design stuff and think through tricky questions and find an exercise or find a resource maybe to help build something up for your students. So we're dealing with this conflict of expert knowledge, of novices learning, and of trying to understand, well, how do we even label our materials? How do we put stuff together? How do we list out the things that we're interested in? What the tool we're going to look at here in a minute is about some core areas of cyber literacy for GI science. Eric Shook, myself, Karen, and a whole host of other folks, some of whom are on this call, wrote this together a few years back. I guess this is 2019. And this very paper will be in the download I'll be giving you shortly. And so we kind of thought through and said, okay, if we think of this on a couple of different axes of cyber literacy of GI science, we probably have two columns, let's say, of GIS and computational science. Those are two areas that we know are going to be working together. Then we have technologies as one row, the tech, the stuff that we're working with data in, and so on and so forth. And then we have problem solving methods. So we have the tools that we're using and the way that we're solving problems. And we came up with this integrated overlap of all those different things and came up with 8 different areas of cyber literacy. So you can see in our lovely colorful bubble that where GIS and technologies align, we call that spatial modeling and analytics. Where problem solving, GIS, and computational science all overlapped, we said that was interdisciplinary communication. So the full description of all of these are in the tool or in the file download and in this paper. So, but you could say to yourself, well, I'm not interested in big data, or I'm not interested in spatial thinking, and that'd be fine. But maybe you have goals in your degree. Maybe you have learning outcomes in your degree. Maybe you have some kind of core competency that you know is important in the data science or the geospatial work that you're operating in. Maybe you have some other kind of learning goal or learning objective that you want to center in your work. You could take this tool, delete whichever ones of these you don't like, and put in your own topics and scope those yourself. So this is a base of what knowledge. You know best what knowledge is most important. So we have knowledge, we have some sort of scale of knowledge. And this is where our old friend Bloom's taxonomy comes in. Bloom's taxonomy is very common in the learning sciences and pedagogy and curriculum work, which basically poses the idea that there are levels, or at least there is some kind of hierarchy of learning and of knowledge that then allows people to, or allows us to structure what people are doing in some kind of order and sequence. So at the bottom of Bloom's taxonomy, we have the remembering and the understanding. So you have to know some facts and understand what those facts mean before you can really do anything else with them. If I don't know what raster data is, then I probably won't be evaluating or analyzing it anytime soon. If I don't know anything about spatial distributions, might need to learn that first before I start applying my knowledge of spatial distributions to my data sets. And so it continues up from there. So this is kind of a general set of terms. Bloom's taxonomy has evolved throughout the years. This one comes from Arkansas's teaching support group. And then this one from Iowa State's teaching support group. So you can see again, every university has one of these. Same idea, ordering the thinking skills, remember, and there are lots of other words there. You might have done, it's a very common curricular activity to pull out like a syllabus or something and rank all of the learning objectives and say, oh, well, this learning objective says that students will detect spatial differences in data. Okay, that's an evaluate skill. So you may have seen this before. This is but one hierarchy, one scale of learning, of thinking. And there are many different dimensions to how this has evolved over time, but it's a very common one. It's a really good one to engage with. So as we're thinking about knowledge, as we're thinking about scale, we're getting to the structure and order of this tool and of these matrices. So what I'm going to do next is pull up one or two examples here. The examples I'm going to use are from the convergence curriculum. So I'll pop that link in the chat just so you can see that. I'm going to give a little demo of how this tool works, of how this tool looks. We'll have some Q&A just about the general structure of it, and then I'll give you work time after that to start scoping out some material of your own. So here's where I'm pulling these materials from. That's that link right there. I'm going to switch my share here real quick to my bundle of tabs to show off this little example. So let's go to the tabs. There they are. All right, that looks good to me. So now we're into all of my tabs. And so this link that I just put in the chat will take you right here, the convergence curriculum. We're back with our chart. Everything's good. We've got some recorded VCOs and forums. That's great. I'm going to be talking about a couple of these examples here, convergence curriculum components. So we're going to be talking through those. Now, this tool lives in my other tab here. So I'm going to move over here for now. As I said, this is coming to you as a file share in a minute or so. Well, 5 minutes, let's say. And it looks like this. It has that paper, the Shook et al. Paper that I noted as one of the resources in a folder. It has some of my example content for the lesson and the assignments and the course syllabus scale, which we'll look at. And then all of the shorter examples are right from the convergence curriculum. So we're using these active things. There is a little instructional documents, which is number 2 here. And so I'm just going to kind of run through this Generally, I'm not going to go through it step by step, but as you look at this later, just so you know what's going on. So here we are in our 3-slide matrices. So as you can see, we have, for all of these conversions curriculum materials, there are actually, for each of those different things, 3 slides about every single one of those topics, which is really neat. And kudos, I did not do any of these. Kudos to everyone who put these together, because putting 3 slides together on any of these topics is a big ask and a big lift. You might say just 3 slides. It's probably harder if it's just 3 slides. So we've got 3 slides for all of these topics, which is super exciting. And what I did in the tool here was evaluate them on these first 2 Bloom's taxonomy levels. And the idea here was we were taking the topic, talking about its purpose a little bit. Why would we be interested in using these 3 slides in our work, in our education? Talking about some of the key terms that came from there, and then scoping them out. After a student's done with these 3 slides, what are we expecting of people? Where are we expecting that they are in this scale? Now, obviously, for 3 slides, you're not going to really get to create after 3 slides if someone's coming into a topic new, even if someone's coming into a topic with a lot of experience. So expecting to create something might be a stretch after 3 slides. But in this case, we've got just the first 2 levels on here. Remember and understand. I think it's very reasonable after 3 minutes to be able to remember some kind of fact and maybe understand how that fact works in practice. Then there's a space for notes. And so this blank template is something you could use if you had a few slides that you regularly use, or a few slides you'd really like to, just kind of settle on better in terms of how they fit into a course. So let's pick one of these topics. Let's pick geospatial. Geospatial. So geospatial has its 3 sentences here, and that's got its 3 slides. Geospatial data, great. Some examples of geospatial data, and some example questions or examples, ways to think about this stuff. Pretty great, pretty fantastic. We love to see those 3 slides. Now I could go to geospatial in my little document here, and I've got my kind of paraphrased purpose, some key terms that came out of that, and what I scoped this out. All of these examples I scoped out, so feel free to argue with me in the chat if you think they should be scoped differently. But that's another key piece of this, is that whether you're scoping out learning materials like this or working within, our various university forums and committees and stuff, we might have different ideas about how things are operating within a curriculum or whatnot. That's fine. That leads to good discussion down the line. In my case, I said, okay, well, geospatial really didn't touch on any of these components, but it did touch on spatial thinking to a point where I think there's some understanding in there, especially in that last slide. It says, if I hop back here, if you're sitting on a bench, can you come up with some different types of geospatial data you could use to describe and measure? And so for me, if I go back here, I say, okay, that's actually understanding spatial thinking to the point of, imagining yourself in a place, understanding what a place looks like. I think that's actually pretty high. We talk about geospatial data. We gotta know what that term is. We talk about some modeling as well. So now so that's one example of how that works. Wait a second, Forrest, what are all those abbreviations? Well, they're from our paper and they're all defined in abbreviations and definitions at the end of the Excel sheet. So spatial modeling, geospatial data. What is spatial thinking? Oh, the ability to consider and manipulate representations of spatial objects and relationships. Great, fantastic. So you can see how many of these there are in one of these examples. We could do, one of the 3-hour pieces that we have. So that's another matrix in here. Geospatial computing was one 3-hour matrix. I'm not going to try to go through 3 hours of slides, but I could say that, okay, so we've got this 3-hour set of materials. From my reading of it, you definitely had to have some cyber infrastructure and computational thinking and other components coming in to even be able to access that. And then at the end, yeah, there's a lot of growth. after 3 hours. And I think that whether it's an assignment and certainly a course, but if there's an assignment or if there's some kind of lab that people are doing, yeah, you're going to get a lot out of that material after 3 hours or after how many hours it takes to use the thing. And that's kind of what the more matrices talks about. So again, another blank one for you to use. And I used a couple examples from my own work in here. Those examples are also in the folder that I'll send. So here's a 15-minute lesson on database fundamentals. Now, this is really important because I know coming in, I've already taught students about file management. I've already taught them a little bit about thinking computationally, thinking what a file path is, how file paths work while they're important. I wouldn't teach database fundamentals the first day, or if I were, I wouldn't teach it like I do in this example. I've already exposed students to some of that knowledge. And I know they've been exposed to that knowledge because they've been in the class. And then after, not a big change in this one, but I'm hoping that after this 15 minutes, they've got a better understanding of geospatial data so that we can advance to more complex stuff after we get these kind of basics down. These slides are in here. It's about joins. There's a cat. There's always a cat. Then I have a sample assignment. Same idea. More growth in the assignment. And then I have a course syllabus. So this is my introduction to GIS course. This is how I scope it out. I really expect students to only have some kind of interdisciplinary communication understanding. I expect them coming in, and I emphasize in the first class that GIS is for everyone. And we're going to see a lot of different examples and a lot of different use cases. And so I want them to understand that GIS is not a narrow thing, it's a broad thing. That mindset coming in sets them up for the rest of the growth. I don't expect anything else. So, but I expect that they're going to be growing a lot. They're going to be making something by the end of the course, a unique and individual combination and analysis of spatial data. Oh, look, geospatial data and spatial thinking has create levels. Perfect. I don't have any parallel computation in my Intro GIS course, so it's the same. So this is kind of the idea of the tool, is that you have some examples, you have some tangible examples, you have real things. It's not just examples out of nowhere. You can look at them, you can see them. It's got some steps to be able to go through that and some good resources to reflect on. So I'm going to pull that down real quick. I have my zip file of all of this information, which I'm going to put in the chat now. But before we move on to a little bit of doing this yourself, I was wondering if anyone had questions before they got their hands on the tool. Perhaps you're all busy downloading the tool, which is great. So I've put it in the chat. So that is the little zip file that you just saw in the file share. What I want you to do is open that up, unzip it. If you don't know how to unzip things, I'm happy to explain. That's something I say in my first GIS class. In fact, we have 2 pages in our first lab now on how to unzip stuff because we learned that download and unzip the GIS data was not something that everybody in class could do without explanation. So if you need help unzipping, let me know. But otherwise, download that zip folder, unzip it, peek around in the materials, start thinking about one of your courses, one of the things you're trying to learn, one of the things you're trying to teach. I think we'll do 10 minutes or so, and if I had hold music, I'd play it, but I don't. So 10 minutes, I'll put off the camera. We can just listen, or we can just look through the materials. We'll come back and we'll talk about, we'll encourage some more active discussion about your experiences in the classroom, how this might be useful, how it might be improved. So let's say 10 minutes, maybe 9, and we'll all come back together. All right?
Thanks. Forrest, when we come back, I'd love to hear your thoughts. This is Diana Sinton. I'd love to hear your thoughts on how you apply these types of frameworks to differently from materials that you might find out there. I'm thinking specifically about geospatial open educational resources
Mhm.
versus the things that you are producing yourself. How you regard and uh, the process you might go through in reviewing things that you find out there, like OERs,
Yeah.
and subject them to this type of process.
Yeah, that's a great question. I'll definitely start with that one, Diana. Thank you. just offer a quick 1 minute or so, and we'll come back with any questions, discussion topics, reactions, feedback, and the like. Diana's already got a question staged, which is great. So another minute. All right. Well, hopefully that serves some useful time to even just think about a class, a lesson, a syllabus. I think you could do something like this for a degree program. There's a lot of fun things that you can do, any scale. I hope this is adaptable for. Now, Diana left us with a great question before we took a little break, which was about how we might use this differently for open educational materials and our own versus our own materials, how we might scope stuff out. And I'm glad you gave me time to think about that one, Diana, because that's a great question. I think my initial reaction is that I would actually find this. I found this easier when I was building this out and building out the examples. I found it easier to do with other people's stuff because I could come in from a not embedded mindset, from a place of looking at things more objectively, and be able to say, oh, well, this is where people are going to go. This is what is required coming in. I think I was able to organize and sort stuff for myself, a little bit easier that way. It's also very useful, just even if it's not a full matrix, just a checklist when you look at an open educational material, or when you look at something that you find through whatever repository, you just kind of keep in your mind yourself, okay, this walkthrough has a lot of advanced R code that isn't explained how to import. So students are already going to need to know how to import this R code or whatever. Oh, they're using, spatial analysis tools that have really in-depth explanations about them. This would be good for someone who hasn't used that tool before. So I think it's always about, kind of building that scoping and kind of putting yourself in the place of learning something, which is easier for me with open educational stuff. My course I have developed over years of practice and years of kind of, oh, it makes sense to me. And then someone asks a question, I go, oh, right, of course I forgot that screenshot because I just know what that tool looks like. So I think it's useful either way. And I think that, in terms of the mechanics of doing these things, it'd be a great way to assess OER stuff as you're looking for things to add to a course. So hopefully that gets at the question, Diana. Excellent question from the chat. Thanks, Sada. Back to the mini survey, file management skills. Desktop is valuable to teach, but operating systems are a hurdle. What are thoughts about replacement of online GIS versus desktop GIS? What to do for each one? I really think that you could teach a full intro to GIS course using Arc Online as the GIS software. And you could teach an intro GIS course using anything. You could use Q, you can use Arc, you can use use R. I think I'm starting to become an R convert. Not that I know any R, but I'm starting to trust it a lot more in terms of a novice accessible way to do GIS stuff. I think online GIS or Arc Online or whatever, if it has the kind of core components of what GIS can do, display, analyze, communicate spatial analysis and spatial data, I think you can use it for GIS. Cloud data has its own universe of file management issues and topics, of course, which is fine. And I think that you can teach very broadly file management in many different categories or in many different ways. It's not just, I do think that if you're only teaching desktop only, you download the data and you put it in a folder and you analyze it there. If that's all you're teaching, you're missing out on a lot of what modern GIS and modern geospatial work is, which is sharing and hosting and streaming and all of those other type of data things. So I think it's totally doable. The core components of file management and managing outputs, all those kind of core computational things are going to be present no matter what. Maybe they have different shades depending on what shadow you're under in terms of your software environment. Other questions? We got about 5 minutes. Thanks, Peter. Thanks, Sana. Good to see you both. Since the form was mentioned, I'm just going to go back to that real quick and see if any other interesting comments have come in while someone thinks of the last question. Let's see.
Forrest, while you're thinking about that, this is Diana Sinton again.
Yeah.
I'm wondering if you could share any thoughts you have on the role of instructors evaluating their materials, or regardless of where the materials came from, but the role of evaluation and reflection as an instructor. Is this something that you find many others of your colleagues at UMass do as well?
That's a great question. There's definitely, we have a lot of thoughtful discussions about instruction at UMass, especially in the GIS space. Part of it's because we just rely on each other to understand how students are progressing through the pathway. We have a 1-year MS Geography GIST program here. So 1 year to take, 24 credits and an internship worth of courses gets the degree. And so we have to be very sensitive to making sure that our courses are accessible to students within that quicker pathway. So some students come in without any GIS experience at all. And some people come in with a lot of GIS experience. So we kind of have this web of options, but we need to know. Thanks, Sasha. One of our GIS instructors just left, said thanks in the chat. But we have to know, for example, if the student's in my intro GIS class and they want to take Dr. Stepanov's spatial database management class, we have to talk to make sure that someone as a novice GIS learner can at least progress within GIS to be able to progress within a data management class, a data interoperability class. And we've talked and they can't. And it's really fantastic to see people weaving the knowledge between the two, because they're learning FME as they're learning Arc Pro, as they're learning about spatial thinking, as they're learning about file handling, and it works really well. Where we get challenged, I think, more is just trying to figure out, okay, where do the courses exist that have to absolutely have a prereq? So we have a GIS 2 course. You have to take GIS, the first intro GIS class there. And so that communication is vital, because we can't, and this serves all students. Again, GIS is for everyone. So it's not just the 1-year master's students, but it's our PhD students and our undergraduates too, who also need clear pathways. The undergraduates need to know, I take this course and then I can unlock, these next 4 courses. We kind of have an issue right now with a course that we have called computer mapping, which is a great course. You make a map every day in class. It's a fantastic practical course, but you don't necessarily need to have intro GIS first. And in some cases, some of the computer mapping stuff might feel, like the student said in the form, might not feel that challenging if they take that course second. So we're always talking and trying to figure out the right ways to do it. It's a challenge because, we have, great faculty and great graduate students who teach these courses, but we don't have a lot of, permanent faculty. We work a lot on instructors to, temporary instructors, temporary lecturers, and grad students and stuff. It would be nice if we had more permanent faculty who we have longer term discussions about this.
So it sounds like that in order to ensure that pathways are possible and viable and ultimately successful, there's important communication across the instructors to really understand
Yep.
expectations and what's going on by the end of the course, and that learning objectives are not just something on the paper, but actually can be achieved so that the students are able to move up that Bloom's, move
Yeah.
up the Bloom scale.
Yeah, absolutely. And I think that those formal discussions are really important. Before we close, because I know we're just at one, but I see Rob's comment. Automatically generate matrices from course descriptions. I love that idea. I think my mind is you need a syllabus. I don't think course descriptions are good enough. I'm reminded of an AAG presentation I saw a few years ago. Oh, I can't remember who now, but they said, I looked at our course descriptions in our catalog at my university, and the cartography course hadn't been updated since 1978. So I don't think course descriptions are the right thing, but I think that you could probably do some kind of language model to pull from a syllabus and with some predefined sorting. That'd be a fun project. I'm down for that. Thanks everyone. Yeah, thanks everyone in the chat. Anand, I don't know if you have any closing words or Xiaowen, but it seems like we had a fantastic hour today.
Yeah, I would say thank you. I would just echo everyone in the chat saying thank you, Forrest. It was really, really a good thought out presentation, as well as kind of getting the audience to interact and think about stuff that we were doing in our class, which is wonderful.
Mhm.
And I think the whole iGuide would definitely benefit from this perspective.
Yeah,
Thank
feel
you.
free. Yeah, feel free anyone to reach out. I'll put my email in the chat, but there's not too many Forrest Bullocks rolling around the world, so I'm always a Google search away. If you have any other questions or whatnot, feel free to reach out anytime.
Again, thank you again, Forrest. And thank you for everyone for attending.
Yeah, thanks.
And keep connected to iGuide through our various social medias and channels. And you will hear about the future VCOs and other activities that we are doing. Thank you.
Perfect.
Bye.
See you. Bye.
Bye everyone.
Thanks, Forrest.
Absolutely. Thank you, Sean.
Hope to see you soon.
Absolutely.